Water treatment, electromagnetic energy, Magnation. Now, I don't know if you've heard of this device. I have 10 years experience working with magnetic resonance. I've worked with UC Irvine, I've worked with the SCGA, the NCGA, I've worked with University of New Mexico, UC Riverside. You cannot test water on the front side, run it through electromagnetic energy and test it on the other side and look at a standard water test. It's not a filter, it's a treatment system. What it does is it induces extremely low frequency resonant energy into the water. It uses the EC of the water as a conductor. And when you hit 7.82 hertz, which is smack dab in the lowest of 5 frequency ranges known as Schumann's resonances, what happens, it'll travel for miles. So you can actually get the benefit of this field breaking up the water molecules, reducing surface tension, and using less water to stay better hydrated. And that's what I've seen, and I just finished an 8-month case study at a golf course who always lost the bottom of the fairway. They used recycled water out of 36 holes. It was their worst hole. So what I did is I fit 3 2-inch Magnation units on lateral fairway lines. So that way we had an area that had nothing but magnetically treated water. Then we had a transition zone that got cross-contaminated, and we had an untreated zone. Some of the things that, and I'm going to show the pictures from that study because we just concluded November 1st. Schumann's resonance are 5 distinct frequency ranges. ELF is known as extremely low frequency, and that's energy. It travels for miles. That's how they pick up earthquakes halfway around the world. Waves crashing on the shore, extremely low frequency resonant energy. It drives the aerobic metabolic pathway. It's antagonistic to pathogens. In fact, when we did the study with Dr. Earthman at UC Irvine, what we found, first of all, he thought it was plugged in because he was picking up the electrical pulse like a heartbeat. And whereas it's not. It's rare earth magnets that's creating this frequency. And what ended up happening is the iron-fixing bacteria fell out of active state into spore state. We also disrupted scale formation in the piping. What it did is soften the scale. It ruined the housing that the iron-fixing bacteria was using as a home to protect itself while it was eating the walls of the pipe. At the end of the day, we vacuumed up the bottom of the aquarium because this was all testing that we were doing, and we didn't have any more problems with scale or iron-fixing bacteria. We also saw the same thing at a nuclear reactor at 3 Mile Island, which drew water from the river down below to cool the reactors. They were actually introducing balls that had sandpaper coating on it. And they were putting it at the input, letting it run all the way up to the discharge, and then collecting them. And it worked at disrupting the scale formation, but it didn't work on the fittings. So the fittings still rotted out. They put on this magnetic system, and they found it disrupted the scale, disrupted the iron-fixing bacteria, and they didn't have the problem with having to replace the pipeline. At that time, it was about $1 million a mile to replace. It introduces nanobubbles. Again, you can't visibly see these. You have to use a micron microscope. So a lot of people that put down this technology aren't looking at the right technologies to determine what this type of treatment is actually doing to the water. So you're getting nanobubbles, remote soil O2. You're also inducing photons into the water. It reduces surface tension, and yes, we did buy a very expensive tensionometer. We tested the water before it went through the magnetic field and after, and we saw a reduction in surface tension. So that was something that was measurable to the normal layman. The price of a tensionometer is very expensive, though. At least the one that's used to reduce surface tension. There are other tensionometers that don't do what I'm talking about. Better water infiltration and percolation, we've seen a 10 to 30% water reduction. With Black Hawk Country Club in Danville, what we did is we started equal amounts of water. After 2 months of treating, we went to a 10% deficit. After 2 more months, we went to a 20% deficit, and that's where we stayed through the end of the trial. We also, one of the big benefits, and Berenberg Seed did a study on this. They actually ran seed through that magnetic field before they applied it. Germination went from 89% to 98% and also germinated quicker. So that was huge. And when we did the study at Black Hawk, we saw the same thing. The untreated, maybe 10% of the seed had germinated. In the transition zone, we maybe had about 30 to 40% that had germinated. In the treated, all the seed had germinated. The difference was night and day, going from untreated to treated. So I happened to pick the right day to visit the golf course. If I had been there a week later, it only would have germinated. But it just illustrated how you can expedite and help become more successful, because sometimes you're pushing the envelope when you overseed. It's getting close to the end of the season. Same thing with aerification. It seems like general managers are pushing back aerification dates. So whereas we used to aerify always in September, started moving into October. Now I have customers who are aerifying the first and second week in November. That doesn't give you a whole lot of time to heal. And if you don't heal before it gets cold, what's going to happen? You're going to be looking at those aerification holes all winter long. Oops. So here, this is, again, on July 28th, we started this trial in April, now about April, the end of March, 1st of April. On July 28th, I was taking soil tests on a monthly basis, and we were taking EC readings on a monthly basis. This is the untreated versus treated fairway, fairway 3 on the Lakeside course, Blackhawk Country Club in Danville, California. On the untreated, do you notice that brown line right there? This fairway would not drain. And using recycled water, they have been top dressing for the last 8 to 10 years. They built up a 3 to 4 inch sand cap. So there is a sand cap on this. But where they cut in drains, dehydrated very quickly. When you look at the transition zone, you can still faintly see the drain lines, but when we got into the treated area, we couldn't see them because of better availability of water. Again, breaking up the water molecule and actually becoming more available to the plant. So even if moisture levels were lower, the plant had more available water. Otherwise, if you have high salinity, the amount of water that is available to the plant is limited. About 2 weeks after overseeding, 3 weeks, this was on October 5th, and we had overseeded in about the middle of September. I asked the superintendent to pull 4 plugs from treated and untreated. This was the resulting picture. So you can see that the untreated has a shallower root system and less mass, and the treated has a stronger root system. It's deeper, and it has more mass. Better ability to pull up water and nutrients, which is going to make it stronger, which is relative to this last slide. November 1st. We've gone 8 months, no rainfall, not a drop. So untreated versus a treated fairway. The untreated, you'll notice out here, we sent this off to Jenny McMorrow at Turf Diagnostics, came back as rapid blight. Rapid blight is a slime mold derived from the ocean. When sodium gets up to a level of 110 or more parts per million, it becomes a conducive environment for it to become active. And because we had had little rainfall, we're using water that has 100 parts per million sodium in it, they started seeing the detrimental effects of rapid blight and turf that was browning out. Here's more untreated turf going into the transition zone, and this was the treated area. We had maybe 1 to 2% that was affected versus about 50%. And one of the things that we did is we actually read, and we read an EC meter, a direct EC meter. So we were going down and chasing the salts. So unlike a Pogo or a Scoutmaster from Spectrum, what we did do is we actually would go into the first quarter inch, half inch, inch and a half, 2 inches, and watch the reading on our direct EC meter. We used distilled water to make sure the salts were in solution and we could properly measure resistance. What we found was the treated area, our biggest concentration of salts was down about 4 to 6 inches. On the untreated, the salts were up in the upper 1 inch, which again is impeding air pore space, the ability of water to infiltrate and percolate. So I wanted to show these trial pictures because they're brand new. I haven't even written the report of the abstract yet. But I thought this was pretty cool to illustrate some of the benefits of the electromagnetic energy.